Welcome to Pulsar's Career Point. This is the marathon series for AGC 2025 as per the modified question pattern on chapter Chemical Kinetics on the questions of type group D. अर्थात descriptive question 5 मार्क जो प्रत्येक यूनिट आसो पिलामानकर आवश्यकता को नजर रखी मु प्रथम केमिकल ग्रुप डी रो जो प्रोबेबल लॉ क्वेश्चन पर आम डिस्कसन करवा. Let us come for the question number 1. Define zero order reaction. There are the equations for rate constant for zero order reaction. Explain how does its half-life period depends upon the initial concentration. पिला माने zero order reaction को नहीं दुई प्रकार क्वेश्चन हो पार. गोटे डायरेक्ट क्वेश्चन एमती रही पार जीरो रिएक्शन टी कौन गोटे एग्जांपल टे देवा को पड़ो तार रेट कन्स्टांट इक्वेशन टी को डेराइव करने को पड़ो एवं इनिशियल कन्संट्रेशन सहित तार हाफ लाइफ पीरियड किपर डिपेंडेंट देखा पड़ो. अदरवाइज यहाँ भी एमती भी हो पारे जीरो रिएक्शन रेट कन्स्टांट को डेराइव करने को कह सहित प्रोब्लेम टी आसीपर. ये देखा व्हाट इज जीरो ऑर्डर रिएक्शन. The chemical reaction whose rate is independent of concentration of reactant is called a zero order reaction. जो chemical reaction rate reactant रो concentration पर independent थाए हमें ताको zero order reaction बोली कही थाउ. Let us come for example H2 plus Cl2 in the presence of diffuse sunlight or H nu gives 2HCl gas. Here the rate of the reaction does not depend upon the concentration of H2 and Cl2. Now let us come for the derivation of rate constant for zero order reaction. Let us consider a reaction A gives us product. Now let A0 be the concentration of reactant at time t is equal to 0 and A be the concentration of reactant at time t and K0 be the rate constant of the reaction. हमें भाविबा A0 होची तार initial concentration, A होची concentration at time t and K0 be the rate constant. Then according to law of mass action or rate law, rate is proportional to A to the power 0 implies rate is equal to K0 into concentration of A to the power 0, that is rate is equal to K0, that is something to the power 0 is equal to 1. According to rate equation, rate is equal to minus dA by dt. Decrease in concentration with respect to time. Decrease in concentration of A with respect to time is rate. देखो हम इक्वेशन 1 रे कहूचे rate is equal to K0, इक्वेशन 2 रे कहूचे rate is equal to minus dA by dt. So from equation 1 and 2 we can write minus dA by dt is equal to K0. Rearranging this equation we can write down minus dA is equal to K0 dt. Let it equation number 3. Now by integrating both sides of equation 3 we get integration of minus dA is equal to K0 integration dt, that is minus A is equal to K0 t plus C, where C is the integration constant. Let it be equation number 4. Now when t is equal to 0 then concentration of A is equal to concentration of A0. Putting this value in equation 4 we get C is equal to minus A0. Now putting the value of C in equation 4 we get minus A is equal to K0 t minus A0 implies K0 t is equal to A0 minus A implies K0 is equal to A0 minus A by t. This is the equation for rate constant of zero order reaction. Now let us come for the half-life period. Half-life period for zero order reaction. What do you mean by half-life period? It is defined as the time taken to reduce the initial concentration of the reactant to half of its initial value. It is denoted or represented by the symbol T half or T 0.5. If the initial concentration of A is A0 when T is equal to 0, then at T is equal to T half, A is equal to A0 by 2. कारण डेफिनेशन कहूँ टी हाफ से टाइम जो भितर इनिशियल कंसंट्रेशन अधा हो जाए अर्थात टी इज इक्वल टू टी हाफ हेले कंसंट्रेशन ऑफ ए इज इक्वल टू A0 by 2. पुटिंग दिस वैल्यूज इन इक्वेशन 5 वी गेट K0 is equal to A0 minus A0 by 2 by T half implies k0 is equal to a0 by 2 t half, implies t half is equal to concentration of a0 by twice of k0. This is the equation for half-life period of zero order reaction. Thus, this equation indicates that the half-life period for zero order reaction is directly proportional to the initial concentration of the reactant. Now, let us come for another question. Define first order reaction. Derive the equation for rate constant for first order reaction. ତା ସହିତ ଗୋଟେ ପ୍ରୋବ୍ଲେମ୍ ଏଠି ଦିଆଯାଇଛି। ଆପ୍ଲାଏ ପିରିୟଡ଼ କଥା କମିଟ୍ କରିଛୁ। ଏଠି ବି ଆପ୍ଲାଏ ପିରିୟଡ଼ ଆସିପାରନ୍ତା। ଆପ୍ଲାଏ ପିରିୟଡ଼ ଆସିଲେ ଆମେ ଗତ କ୍ୱେଶ୍ଚନ୍ରେ ଯେମିତି ତାକୁ ଡେରାଇଭ୍ କଲୁ ଏଠି ମଧ୍ୟ ଡେରାଇଭ୍ କରାଯାଇଥାନ୍ତା। ଏଠି ଗୋଟେ ପ୍ରୋବ୍ଲେମ୍ ଦିଆଯାଇଛି ଫାର୍ଷ୍ଟ ଅର୍ଡର ରିଏକ୍ସନ୍ ଟେକ୍ସ 69.3 minutes for 50% completion. How much time will be needed for 80% completion? ଯଦି 50% completion ପାଇଁ 69.3 minutes ଦରକାର ହେଉଥାଏ ତାହେଲେ 80% completion ପାଇଁ କେତେ ସମୟ ଦରକାର ହେବ? First of all, come what is first order reaction? The chemical reaction whose rate is proportional to 1 molar concentration of reactant is called a first order reaction. Come for example, decomposition of H2O2 to give water and O2 is an example of first order reaction. Decomposition of SO2Cl2 to give SO2 and Cl2 is also an example of first order reaction. Decomposition of nitrogen pentoxide to give NO2 and O2 is also an example of first order reaction. Now let us come for the derivation of rate constant for first order reaction. Let us consider a reaction. A gives us product. Let A0 be the initial concentration of the reactant at time t is equal to 0. A be the concentration of reactants at time t, and K1 be the rate constant of the reaction. According to law of mass action, rate is equal to K1 into concentration of A to the power 1 implies rate is equal to K1A. Similarly, according to rate equation, rate is equal to minus dA by dt. Equation 1 कहूँ rate is equal to K1A, equation 2 कहूँ नहीं rate is equal to minus dA by dt. So from equation 1 and 2 we get minus dA by dt is equal to K1A. Rearranging this equation we can write down minus dA by A is equal to K1 dt. Let it be equation 3. Now by integrating equation 3 on both sides we get integration of minus dA by A is equal to K1 integration dt. dx by x or integration क्या ना ln x. तो मैंने dA by A और integration कहते हैं ना ln A. So implies minus ln A is equal to K1t plus c. Where c is the integration constant. Let it be equation number 4. When t is equal to 0, then constant of A is equal to A0. Putting these values in equation 4, we get c is equal to minus ln A0. Now, by putting the value of c in equation 4, we get minus ln A is equal to K1t minus ln A0. Implies K1t is equal to ln A0 minus ln A. Log A minus log B is equal to log A by B. So ln A0 minus ln A can be written as ln A0 by A. Implies K1 is equal to 1 by T ln A0 by A. Taking the natural logarithm, this equation can be written as K1 is equal to 2.303 by T log A0 by A. Let it be equation number 5. ଯଦି ଆପ୍ଲାଏ ପିରିୟଡ଼ କଥା ପଚାରିଥାନ୍ତା ୟାପରେ ଆମେ ଗତ କ୍ୱେଶ୍ଚନ୍ ଭଳି ଆମେ ଆପ୍ଲାଏ ପିରିୟଡ଼ କଥା ଲେଖିଥାନ୍ତୁ କିନ୍ତୁ ଆମେ କ୍ୱେଶ୍ଚନ୍ଟିକୁ ଟିକେ ଅଲଗା ଫର୍ମରେ କରିଛୁ ଏସବୁ ଗୋଟେ ପ୍ରୋବ୍ଲେମ୍ ଦିଆହେଇଥିଲା। ଲେଟ୍ ଅସ୍ କମ୍ ଫର୍ ଦ ସଲ୍ୟୁସନ୍ ଅଫ୍ ଦ ପ୍ରୋବ୍ଲେମ୍। We know that T half is equal to 0.693 by K1 implies K1 is equal to 0.693 by T half. प्रश्न दिया जाइतिला 50% कंप्लीशन ପାଇଁ 69.3 मिनिट दरकार अर्थात T half दिया जाइतिला। So 0.693 by 69.3 is equal to 0.01 minute inverse is K1. Again T is equal to 2.303 by K1 into log A0 by A or N0 by N. जेहेतु सी 80% कंप्लीशन कथा कही अर्थात N0 जदि 100 हुए A0 जदि 100 हुए देन A by N 20 हम अर्थात 2.303 by 0.01 log 100 by 20 that is equal to 2.303 by 0.01 into log 5. Now डायरेक्टली आम log 5 रो वैल्यू पकई पारिबा किंतु एठी आमे 5 को 10 by 2 फॉर्म को नहीं log 10 minus log 2 अर्थात 1 माइनस 0.301 value यूज करिछु सो द आंसर इज 230.3 इंटू 0.6990 लॉग टेबल थिले डायरेक्ट वैल्यू पकई हम जेहेतु आमको लॉग टेबल पाखे नाला आम कौन कलु 5 जगह लॉग 10/2 करदेलु सो लॉग 10/2 इज नथिंग मान लॉग 10 माइनस लॉग 2 वैल्यू जनाता पकई दिखाई यापर आम टी कैलकुलेशन वैल्यू पाइबू 160.97 मिनिट thus the time required for 80% completion of the reaction is approximately 160.97 minutes. This is the solution of the given problem. Thanks for watching Bhopal Sir's Career Point. Best of luck for the upcoming examination.